Let's work some problems. Let's look at an adiabatic expansion. If I have 3 moles of oxygen and that gas expands adiabatically, the temperature drops from 450 Kelvin to 250 Kelvin. Let's answer these 3 questions. How much heat is transferred? What is the change in internal energy? And how much work is performed? Well, first of all, this is an adiabatic expansion. That means there is no heat exchange. Q equals 0. Internal energy change. Well, we can go back to our kind of old calorimetry idea here, that the internal energy is the number of moles multiplied by the heat capacity multiplied by the change in temperature. Heat capacity is not something that we need to know because the question tells us that the gas is oxygen. So it's a safe bet that I have 5 degrees of freedom because dioxygen is a linear diatomic gas. So number of moles multiplied by 5 over 2 times R, and we're going to use the 8.3144 joules per mole per Kelvin form of R, and then multiplied by the change in temperature in terms of temperature final minus temperature initial. That's going to give us a negative number. And the Kelvin and the per Kelvin cancel, and the moles and the per moles cancel. That gives me a number in joules. And because of the negative temperature change, this is negative 12,500 joules. That's a negative value because the temperature decreased. As temperature decreases, internal energy must also decrease. Okay, work performed. Well, work and internal energy are just the opposite of each other. Work is positive for an expansion, so the work is plus 12,500 joules. Let's look at a slightly different question. It's another adiabatic expansion. Chlorine, another diatomic molecule, expands adiabatically from 0.2 cubic meters at 900,000 pascals up to 0.8 cubic meters at 200,000 pascals. Calculate the work performed and calculate the change in internal energy. Well, W is the negative CV over R of P2V2 minus P1V1. Now, because it's a diatomic gas, CV is 5 over 2R. So we're going to put 5 over 2R in here, and these R's are going to cancel. I'm going to put the end pressure, the end volume, and then subtract from that the initial pressure and the initial volume. So minus 5 over 2 multiplied by 160,000 minus 180,000. This is a negative term, and I have a negative term here. So when I multiply these two together, I end up with a positive number. And because I know that the question is asking about an expansion, I should be expecting a positive number. If this number isn't a positive, then go check your work because there's a mistake in there somewhere. And we come out with 50,000 joules, so 50 kilojoules. Internal energy here is, internal energy is the opposite of work. So just flip the sign and the internal energy change is 50 kilojoules negative. Let's look at an isothermal example. 2 moles of gas expands from 2 liters to 6 liters at a constant temperature of 300 Kelvin. Find the internal energy change, find the work performed, and find the heat that is transferred. Okay, so delta U equals N CV delta T. But delta T is 0 because this is isothermal. The temperature remains constant, so the change in temperature is 0. And if this term is 0, then delta U is 0. So the internal energy change is none at all. Work performed, W equals N RT natural log of V2 over V1. Just put the numbers in. W is 2 multiplied by 8.3144 multiplied by 300 multiplied by the natural log of 6 over 2. And that gives us a value of 5,480 joules. This is a positive number because it's an expansion. And heat transferred. Well, we know that delta U equals Q minus W. And we also know that delta U equals 0. So Q is also 5,480 joules, because when this number subtracts that number equals 0, that's the value.